Problem 43, we're going to read functions using tables rather than symbolic expressions. We're used to seeing things like this, right? If f of x was, say, 5x minus 3, and you wanted to compute f of 2, you would just put that 2 right in for that x, right? And we'd get 7. But now we don't have a symbolic expression. We have tables. The function's given in terms of a table. So let's get rid of this and see what we can do here. Let's have a look at part A here. What we want to compute is f of g of negative 3. All right, so what did we get here? We're going to start with negative 3, and we're going to put it into the g function. Now, where's the g function? Table 1 is the f function. Table 2 is the g function. So we're going to read it from the table. So look for negative 3, right? Negative 3 is right here. Negative 3 processes to a 2. So what we're going to have here is f of 2. Now, what are you going to do with the 2? We're going to process it with the f function. And the f function is over here in table 1. So if you put 2 in, what do you get back? You get back negative 3. So let's write a conclusion here. What we're saying now is that f of g of negative 3 is negative 3. So what we're doing here is, if we just draw a picture, we start here with negative 3. We apply g to it. That took us to a 2. And then we apply f to it, and that takes us right back here to negative 3. So what we see here is that f undoes the effect of g. G does something, f undoes it. Now, I'm going to claim that this is going to happen for all these other problems. So I'm going to go back up here to B, C, D, E, and F, and I'm just going to say what I think these are. I think this is going to be negative 6. In C, I think this is going to be 2. In D, I think it's going to be 3. And in E, I'm thinking negative 2. And F, that should be a 3. Let's run a quick check on this one here. What's f of 3? Right, put in 3 into f. If you put 3 into f, where are we? This is the f function, right, table 1. Put 3 into f, you get negative 2. Now, that's negative 2. So put negative 2 into g, that's right here, brings you right back to 3. So g says, what can you conclude about the relationship between f and g? Well, apparently, and this is not a proof, so we would suggest almost that f and g are inverses of each other. You know, it's not good enough just to say they're inverses. They could be inverses of some other functions. But we're going to say these examples suggest that they are inverses of each other. It's not a proof. Just because you do this for a couple of them doesn't mean it always happens. So it's just a suggestion.